In this lesson, we'll continue our discussion of statistics, and we'll be talking about measures of dispersion. So our objectives will be to, number one, determine the range for a data set, and number two, determine the standard deviation for a data set. A measure of dispersion tells us how spread out values are, and range is one of the ways we can describe the spread of the values in a data set. That is, the range will tell us how far apart the largest and the smallest values in the data set are. To find the range, we simply subtract the smallest number from the largest number in the data set. So here is an example of range. 8 students were surveyed and asked approximately how many songs they had downloaded in the last week. The results are shown in the table. So we have in our table student A downloaded 6 songs, student B 4 songs, student C 3 songs, etc. In this list, I have listed the values from smallest to largest, with 3 being the smallest, followed by 4, 4, 5, 5, 6, 6, and 7. And the range of this set would be 7 minus 3, or 4. So the distance between the most number of songs that were downloaded and the least number of songs that were downloaded is 4. Now the deviation of the mean tells us how far each number in the set is from the mean of the set. So to find mean, we will find the sum of all of the values and divide that by the number of values. So that would be 3 plus 4 plus 4 plus 5 plus 5 plus 6 plus 6 plus 7, all divided by 8, because there are 1, 2, 3, 4, 5, 6, 7, 8 values in our data. The numerator will add up to 40 if you add these values together. Divide that by 8, and that means our mean, which we know as x bar, is going to be 5. Now we want to know the difference between the original value and the mean. So in other words, how far from the mean is each one of these values in our set here? So this one is 2 below, 4 is 1 below, negative is how we indicate below. So this 4 is also 1 below. 5 is exactly the mean, so that's a 0. So I can see how far each number is from the mean by subtracting the original number minus the mean. 2 below, 1 below, 1 below, exactly the same, 1 above, and actually this should be 2 above. That last number, 7 minus 5, would be 2. Now we want to get the sum of these deviations. So we want to know what happens if we were to add these numbers together. So once again, we have our sigma notation. That means add them up, and this is the difference between the number itself and the mean of the set. So if we were to add these differences, so we've already found the differences, and we add them together, -2, -1, -1, 0, 0, 1, 1, and 2. So watch what happens. Negative 2 and 2 is 0. 1 and 1 is 0. 1 and 1 is 0. We end up with 0. And in fact, the sum of the deviations of a set of values will always be 0 if you've calculated it correctly. So we're working our way toward finding a measure of dispersion, or that is of spread, called the standard deviation. And in order to do that, we have to do something to these differences, because as we saw, when we added up our differences, we just got 0, and that doesn't tell us anything about the spread of the numbers. So our formula is going to involve the square of the deviations. So the square means to multiply the number by itself, and when you square, that is, you multiply a number times itself, the signs will always be the same, so it will come out as a positive result. So we'll get 4, 1, 1, 0, 0, 1, 1, and 4. And now that none of the values are negative, we can actually add these values together. And we don't get 0, we get a number, and in this case it's 12. So the sum of the squares of the deviations for our problem is 12. So we just saw that the sum of these deviations, here's our little formula we just wrote down, that the sum of these deviations is 12. And now we can go on to the last step and find our standard deviation. Now, as mentioned before, the standard deviation is another measure of how spread out the numbers in a set are, and how close are the numbers in the set to the actual average or mean of the set. Now, the larger the standard deviation, the more spread out the values are from that mean. And the formula for standard deviation is the sum of the squares of the deviations, which we found in the last step, divided by the number of values in our set minus 1. So normally we've got our n value, and we know n to be 8. And when we find the standard deviation of a sample set, when we did our survey of those students, we just took a sample of 8 students and found out how many songs they had downloaded. So that's called a sample set. And in order to find the standard deviation, then we'll divide that sum of the squares by the number of values minus 1. So we've got 12 as our sum, and we've got 8 values, so we'll divide by 7, and then we'll take the square root of that. So if you were to do this square root of 12 divided by 7, so now I'm going to switch over to the calculator and take the square root. So I did second and the x squared key to get the square root, which is above the x squared key. 12 divided by 7, and that gives me a standard deviation of approximately 1.309. Now, we can do these calculations on the calculator instead of by hand. And so I want to take just a couple of minutes to show you how you could do this in the calculator. And in order to do that, I'm going to use the list feature of the calculator. Now, I just cleared my list by pressing second and plus and enter. And now I'm going to press stat 1. And you will see your list come up, and I'm going to enter the numbers that we had in our set: 3, 4, 4, 4, 5, 5, 6, 6, and 7. And you'll notice if I put my cursor on the last one, it will say that there are 8 values in the set. And so to do the standard deviation, I am going to use the stat features of the calculator, by pressing Stat. I'm going to cursor over using the right arrow key to the Calc button, and I'm looking for one variable stats. We just have one column, so we're doing those one variable stats. So I'll press Enter, and then I'll press Enter again, and notice what I get here. The mean is 5, and the sum is 40. Remember when we added those numbers together, we got 40? And the standard deviation is approximately 1.309. So we can see those values here listed right here on this screen for us. We enter our values in the calculator. Let me go through this one more time just to show you. I'm going to clear all my lists. You go Stat 1, and then you enter the numbers 3, 4, 4, 5, 5, 6, 6, 7. Cursor to the last number in the set. Make sure you've got the right number. It says 8. Hit Stat. Go over to Calc. Select number 1. Press Enter. And you will get the mean, the sum of all the numbers in the set, and this S followed by X means the standard deviation of those numbers.